Happy morning to all. Happy morning. Okay. In our coordination compound lesson, we learned that the Verniers theory and also the valence bond theory, VB theory. Am I right? The VB theory explained about that bonding in complex. Am I right? Bonding in complex. And already we learned that. And have some limitation in VB theory. Anyhow, today our learning objectives to learn about the crystal field theory. Which theory? Crystal field theory. That is CFT. Crystal field theory. In our lesson, one more theory that is called the crystal field theory. Here, the crystal field theory assumes that there is a bond between ligand and the central metal atom is purely ionic. Okay, that's the first one, very very important. The bond between the ligand and the central metal atoms are purely ionic. That's the first one. Second one, the coordination compound, the central metal atoms and the ligands are considered as a point charge, otherwise called the electric dipoles. The third point. About the second point. Let's say important about the third point. According to crystal field theory, the complex formation is considered as the following series of hypothetical steps. We are having the following three steps. What are the three steps? Here are having three steps. This is step number 1, step number 2, step number 3. Like that, the three steps. The step 1 about that, the d orbitals. The d orbital, all of you know that one. What are the d orbital? That is dxy, dxz, dyz, dx square minus y square and the dz square. Here, the energy of the 5 d orbitals are increases. Am I right? The energy of the 5 d orbital will be increases due to the repulsive force between the electrons. Repulsive force between the electrons, the metal and the ligand. Okay. Let us discuss one by one. Which are the three steps? We should be draw the complex. That means we should be draw the crystal field theory for the tetrahedral complex and the octahedral complex. It's very important. Please all of you take the note and we can be draw the complex. Okay. I told you that I can explain about the crystal field theory having three steps. Okay. We should learn what are the three steps. This is the third point about the crystal field theory. The complex formation is considered at the following series of hypothetical steps. That means three steps. Number 1. What is about the step 1? Step 1. What is the step 1 means? That there have some repulsion between electrons and ligand. Electron and ligand. There is some repulsion between the electron of the metal and the ligand. Here, step 1, all the 5 d orbitals of the central metal ions are degenerate. Okay, that means what is about the degenerate means? The 5 d orbital. Which are the 5 d orbital? Can you say which are the 5 d orbital? That we are saying dxy, dxz, dyz, dx square minus y square and dz square. Here all the 5 d orbitals of the central metal ions are degenerate. Okay, that means all orbital, that means which are orbital? dxy, dxz, dyz, dx square minus y square and dz square, all the orbital having equal energy, same energy. So they are called as degenerate orbital. Equal energy. All equal energy. Okay. In this field, the energy of the all 5 d orbitals will increases. The energy will be increases. That's a step 1. Don't forget that. In this field, the energy of the all 5 d orbital will increases. Why? Due to the repulsion between the electron of the metal and the ligand. Okay, this due to the here. We say about that all the 5 d orbitals of the energy, okay, will increases. Energy will be increases. Why? Due to the repulsion between the electron of the metal ion and the ligand. This is the first condition. Okay, first step. What is about the first step? Can you say? All the 5 d orbitals of the central metal ions are degeneracy. Okay, degenerate. What's the meaning of degenerate? Degenerate means what? All the orbitals having same energy, equal energy. Which are the orbital? dxy, dxz, dyz, and the x square minus y square and dz square. Here in this field, the energy of the all 5 d orbitals will increases. Why? Due to the repulsion between the electron of the metal and the ligand. That's the first step. Second step. What is about the second step? Okay, second step. Here, the ligands are approaching to the central metal atom. Here, the ligands are approaching the metal atom in the actual bond distance. What is about the second point? The ligands are approaching the metal atom in an actual bond distance, having some bond distance. Okay. The ligands are approaching the metal atom in an actual bond distance. Here, the degenerate orbital now split into 2 sets. Degenerate orbitals. There is the 5 orbitals. What are the 5 orbitals? What are the 5 orbitals? dxy, dxz, dyz, dx square minus y square and dz square. These are the 5 orbitals. Here, the degenerate orbitals split into 2 sets. Which are the 2 sets? We are saying Eg and T2G. Okay, here I told you that the degenerate orbitals, the d orbitals split into 2 sets. This is one set, this is another set. What is about the first set? Here we are saying Eg and the second set is called T2G. What is Eg? Eg means doubly degenerate orbitals. That is, we are saying dx square minus y square dz square. Doubly degenerate orbitals. Can you see what is about the T2G? We are saying triply degenerate orbital. That is dxy, dxz, dyz. These are the triply degenerate orbitals. And Eg means doubly degenerate orbitals. Can you understand this? Okay, anyhow, here this process, this splitting of 2 sets, this process is called as what? This process is called as crystal field splitting. Okay, the second step is very important. Okay, it's a very important. Here, the degenerate d orbital split into 2 sets. One is called Eg and another one is called T2G. Here, what is about the Eg? Doubly, don't forget that, doubly degenerate orbitals. What is about the T2G? Triply degenerate orbitals. Doubly means dx square, last two we are taking, dx square minus y square and dz square is about examples about the Eg, and about the T2G means dxy, dxz and dyz about the T2G. Okay, anyhow, this splitting process, this process is called as a crystal field splitting. Crystal field splitting. Okay, this process is called crystal field splitting. Next, about the step 3. What about the step 3? Step 3 means when the ligand approach further, there will be an attraction between negatively charged electron. Negatively charged electron and positively charged metal ion. Okay, what's about the third step? When the ligand approaches further, there will be an attraction between negatively charged electron and also positively charged metal ion. This result is in a net decrease in energy. Net decrease in energy. Okay, these are the 3 steps we should be learn about the crystal field theory. The third point. Okay, the crystal field theory about the third point. Already I told you about that. The first 2 points. Okay, the first 2 points is already over. About the third point, I told you that here are 3 steps. What is about the third point? According to crystal field theory, that is CFT, crystal field theory, the complex formation is considered as the following series of hypothetical steps. Okay, hypothetical steps. Here are the 3 steps. What are the 3 steps? The first one is all the 5 d orbitals of the central metal ions are degenerate. Okay, all the 5 d orbitals. What are the 5 d orbitals? The XY, the XZ, the YZ, the X square minus Y square and the Z square. Am I right? Here all the 5 d orbitals of the central metals ions are degenerate. What is about the degenerate meaning? Here all the orbitals are same energy or equal energy. Here in this field, the energy of the all 5 d orbital will be increases. Why? Due to the repulsion between. Okay, here first step 1 is repulsion. Okay, the third step is attraction. Don't forget that. The step 1 having repulsion, step 3 having attraction. Okay, anyhow, here about that the repulsion between the electron of the metal ion and the ligand. Okay, that's the first step. Then about the second step, the ligands are approaching to the central metal ion in actual bond distance. Anyhow, here the degenerate d orbital split into 2 sets. What are the 2 sets here? Eg and T2g. Eg and T2g. What is about the Eg? That is Eg about the doubly. Don't forget the doubly degenerate orbital. Doubly degenerate orbital. What is about the T2g? Triply degenerate orbitals. Here doubly means we are giving example dx square minus y square and dz square about the doubly degenerate orbitals. About the triply degenerate orbitals means dxy, dxz and dyz, and this process of splitting is known as about the crystal field splitting. Next about the third point, when the ligands are approached further, there will be an attraction between negatively charged electrons and also positively charged metal ions. Okay. Anyhow, when the ligand approaches further, there will be an attraction between negatively charged electron and also positively charged metal ion. This results in a net decrease in energy. Okay. Anyhow, we should draw the diagram. What is about the diagram? About the second point, we should draw about that the octahedral field energy. Okay, that is we should draw the diagram. I told you that what is about the first step. Here you should learn the third point. Okay, step 1. Here the step 1 means in an isolated gaseous state, all the 5 d orbital of the central metal ions are degenerate. Initially, the ligand form a spherical field of negatively charged around the metals. That's the important point. Initially, the ligand form a spherical field of negatively charged around the nucleus. In this field, the energy of the all 5d orbital will increases all 5d orbital. Okay, the energy of the all 5d orbital is increases. Don't forget that increases. Why? Due to the repulsion between where? Repulsion between electron and the metal ion. Okay, electron in the metal ion and the ligand. Don't forget that this is about the first point. What is the second point? How can we explain the second point? Second step. What is the second step is the ligands are approaching the metal ion. Okay, the ligands are approaching the metal atom in actual bond distance. Let us we can discuss. We can take one octahedral. Okay, octahedral field. Okay, we are taking one octahedral field. Like this, we should draw one of an octahedral complex. We are taking a 3 axes. Okay, what are the 3 axes? X, Y, and Z. Okay, here having 6 faces. Am I right? How much face is there? 6 faces. Here. How can you explain the 6 face? Imagine this is one of the face. Second face, third, fourth, fifth, and also the 6th face. Okay, clear? Clear? How much face is there? 1, 2, 3, 4, 5, and the back side also having 6th one. So we are taking the axis. Here first of all we are only taking this X. Okay. We are taking here we should be taking Z. Okay. Z. Okay. This side, that side we are taking X. Here we are taking Y. Here we are taking Z. X, Y, Z. Here, just Z opposite we are taking minus Z. X opposite, that is we are taking minus X. And also Y, this is Y. Opposite we are taking what? Minus Y. Okay, anyhow, here we are saying for an octahedral field, okay? In the octahedral field means here 6 ligand approaching, 6 ligand are approaching to the metal ion. Okay, 6 ligand are approaching to the central metal ion. How much ligand? 6 ligand. Okay, first we are taking ligand number 1 here. Ligand 1 approaching. Okay, here ligand 2 approaching here, ligand 3, ligand 4, ligand 5, ligand. These are the 6 ligand. Okay, here the central metal ion having that we know, we already discussed about the lobes. Okay, These are the lobes. Okay. Anyhow, and about that we should be say the axis about the 5 orbitals. 5 orbitals. Which are the 5 orbitals? This the first one is here. This is a dxy. Dxy. Okay. The first one is dxy. Here dyz. Okay. Dyz. Here dxz. Sorry. dxy. dyz. Here dxz. Here dz square. Here dx square minus y square. These are the 5 orbitals. Which are the 5 orbitals? Here the first one is dxy, dyz, dxz, dz square, dx square minus y square. This is ligand number 1, ligand number 2, ligand number 3, ligand number 4, ligand number 5 and ligand number 6. This is an x-axis, x minus x, okay. Next about y minus y, z minus z. Okay, these are the axes. Anyhow, we should tell about that when the central metal ions is located at the origin. Okay, here having 6 ligands are coming. How much ligands are coming? 6 ligands. Which are the 6 ligands? That is plus x to plus x minus x, plus y minus y. Okay, plus z minus z. How much ligands are coming? 6 ligands are coming from where? Coming from where? Plus x minus x, plus y minus y, plus z minus z. Okay, these are the 6 ligands are coming. Here, the orbital, we should say the orbitals lying along the axis, orbitals lying between the axes. This we should be say about the 2 points. Which are the orbitals are lying along the axis? Which are the orbitals are lying between the axis? Here, between the axis means we are saying 3 axes, and along the axis means 2. Okay, 2 axes. Between the axis, which are the between the axis and which are the lying axis? Okay, the orbitals lying along the axis means 2 axes, that is dz square minus dy square. That is lying axis. Whichever lying axis means along the axis. Okay, lying along the axis. Okay, along the axis means dx square minus y square and dz square. This is the orbitals lying along the axis. The orbitals lying along the axis. Which are the axis? Dx square minus y square and dz square. Here, it experiences a strong repulsion. Okay, don't forget that these orbitals will experience strong repulsion. Okay, and it will be raised energy to greater extent than. Okay, it will be raised the energy and to the greater extent than the orbitals in the lobe is directed between the axis. Okay. Axis, which are the axis? dxy, dxz, dyz. Here, what's about the first point about that? The orbitals lying along the axis. Which are the lying along the axis? Dx square minus y square, dz square. Orbitals will experience strong repulsion. Okay, here the orbitals lying along the axis, dx square minus y square, dz square will experience a strong repulsion and the raising energy to the greater extent than the orbital between the axis dxy, dxz, dyz. Anyhow, here the orbitals Which are the orbitals here? 5 orbitals. Which are the 5 orbitals? dxy, dxz, dyz, and dx square minus y square, dz square. Here, these orbitals now split into two sets. Okay, what are the two sets? One is Eg, another one is a T2G. Okay, now split into two sets. One is called Eg and another one is called T2G. Anyhow, I told you that what is about the Eg? It is a what? It is a doubly degenerates. What is about the T2G? Triply degenerates. That means doubly means which are the axis there? Dx square minus y square and dz square. Okay, dz square. What is about the triply degeneracy? Here dxy, dxz, dyz. Okay. Anyhow, this splitting process, the process is called crystal field splitting. Okay, this process is called crystal field splitting. Okay, anyhow, about the third point, I told you that about the third point. What's about the third point? When the ligand approaches further, there will be an attraction between negatively charged electrons and also the positively charged metal ion. Okay, there is an attraction between negatively charged electron and also having the positively charged metal ion. Okay, what happened? What is the result? This result that net decrease in energy. This decrease in energy is the driving force. Okay, this driving force to the complex formation. Let us discuss about the complex for the octahedral complex. Can we discuss about the octahedral complex? Crystal field splitting of CFS. What is about the CFS? Crystal field splitting of octahedral complex. Okay, here during the crystal field splitting, the octahedral field, in order to maintain the average energy of the orbital is constant because all having equal energy. These are all what? Constant. The energy level is constant. Anyhow, this is the dxy, dxz, dyz, and dx square minus y square and dz square. Here now the d orbitals in free ion. Okay, d orbitals are free. D orbitals in free ion. Okay, which are the orbitals? dxy, dxz, dxy, dxz, dyz, dx square minus y square, dz square. These are the 5 orbitals. Here, what is happening means the energy of the orbital dx square minus y square and dz square is represented as what? Is represented Eg. Okay, here this told you that dx square minus y square and dz square. Here it is represented as Eg. The dxy, dyxz and dyz are represented as T2G. Okay, T2G. Here now the d orbitals are in free ion. Now little more the energy is increasing, lightly increasing. This is called what? Average energy level. This is now what? Average energy of the d orbital. Average energy of the d orbital. Here having it is split into two. Okay, split into two. What are they? One is Eg, another one is a T2G. Okay, what is one? It's the Eg and T2G. Here we should draw like that. Increasing. This is what? Eg. Next about T2G. Here I have two orbitals. Which are the two orbitals? dx square minus y square. dz square. Okay. Next here having three orbitals. What are the three orbitals? dxy, dxz, dyz. Okay. Here. Anyhow, this value is called delta delta naught. This is one of the value delta naught. Okay. Anyhow, here the energy is increasing. Here the energy is decreasing. Here increasing means we are giving plus 3 by 5. Plus 3 by 5. Okay. Plus 3 by 5 delta naught. Okay. Decreasing means we are giving minus 2 by 5 delta naught. These are the value. Okay. Which are the two values we are giving? Here, increasing while the three orbitals are increasing, will increase 3 by 5 delta naught. Will the other the remaining 3, because we are having 5 orbital. Out of this 5, 2 of them are increasing and 3 of them are decreasing. Okay, 2 of them are increasing, and 3 of them are decreasing. Here, okay. Increasing means we are giving the value is 3 by 5 delta naught, and decreasing we are giving the value 2 by 5 delta naught. Okay, this is about the octahedral field. Here, octahedral splitting field, crystal field splitting. Can you draw this diagram? This is the diagram for splitting of d orbitals in an octahedral complex. What is about the octahedral complex? Octahedral complex means here having 6 ligands are approaching to the central metal ion. 6 ligands. Octa, don't forget that. Octa means 6 ligands are approaching to the central metal ion. Suppose the question may be asked, draw the crystal field splitting of tetrahedral complex. Tetrahedral complex means 4 ligands are approaching to the central metal ion. Here the diagram is octahedral. Octahedral means 6 ligands. 6 ligands are approaching to the central metal ion. We can discuss about the tetrahedral complex. Okay, tetrahedral complex. Here we are taking the energy level. Energy. This is an energy. Okay. We are taking d orbitals. How much? D orbital. Which are the d orbitals? D xy, d xz, d yz, d x square minus y square, d z square. Okay. D z square. These are the 5 orbitals. Here the d orbitals. Free ion. Okay, d orbitals are free ions. Which are the orbitals? dxy, dxz, dyz, dx square minus y square, dz square. After that, the energy is increasing to the average. The average, okay, average energy. 5 orbitals, okay. The same 5 orbitals, that means average energy of d orbitals in the spherical crystal field. Okay, the average energy of d orbital in the spherical crystal field. Okay, here again this the d orbitals again split into 2 sets. Again split into 2 sets. One is Eg, another one is a T2G. Clear? Can you understand? Okay, as per this tetrahedral, it is first one is T2G, second one is the Eg. Okay, don't forget that the octahedral means first one is the Eg, second one is the T2G. For the tetrahedral complex, the first one is T2G, the second one is the Eg. Here T2G means already I told you about the triple E. Okay, triple E means we should take the first 3. What are the first 3? What are the first three? dxy, dxz, dyz. What are the first three? dxy, dxz, dyz. What about the second one? Easy. Two orbitals, that is dx square minus y square dz square. Okay, dx square minus y square dz square. Here, don't forget that. Like, what is about the energy level? Okay, the first one is increasing, the second one is decreasing. Increasing means we are getting plus 2 by 5 delta naught. Okay, increasing we are giving plus 2 by 5 delta naught. Decreasing we are giving decreasing minus 3 by 5 delta naught. Okay, this is about the diagram for crystal field splitting of tetrahedral complex, and before we learn the crystal field splitting of octahedral complex. Before we learn here, this is the question for the 3-mark question. Draw the crystal field splitting in tetrahedral. Tetrahedral means you should be draw this diagram. Okay, the first one dxy are 5 orbital. Which are the 5 orbital? dxy, dxz, dyz, dx square minus y square, and about the dz square. Okay, dz square about the 5 orbital. After the 5 orbital finished, you should be draw the average energy of d orbital in the spherical crystal field. The spherical crystal field. Okay, this is a spherical crystal field. Here also same only dxy, dxz, dyz, and dx square minus y square, and about the dz square. And about here, in the area, it will be this crystal field. This is split into two sets. One is about the T2G for the tetrahedral complex. The first one is the T2G, and the second one is the EG. Here T2G means triple degeneracy. Okay, triple degeneracy means it should be draw the 3 orbitals. Which are the 3 orbitals? dxy, dxz, dyz, and about the EG, because it goes to 2 orbitals. Which are the 2 orbitals? dx square minus y square, and about the dz square. And also having, you should be draw the d orbitals in tetrahedral Ligand field. Okay, one more diagram also having Ligand field. One more diagram that you should be drawn. Okay, one of the complex. Here I told you that for the tetrahedral complex means how much ligand is there? 4 ligand is there. How much ligand is there? 4 ligand. Okay. The first one ligand is L1. This is the first ligand, L1. L1. This is the first one. The second one is here, L2. The third one is L3. Next about the fourth one is L4. So tetrahedral complex. That means how much ligand? 4 ligand approaching on the central metal line. 4 ligand. Don't forget that tetrahedral means 4 ligand and octahedral means about the 6 ligand. Am I right here? And which are the orbitals? You should be draw the which are the orbitals, which are the x and which are the y and which are the z. Okay. X. This is about the x there. Next about the y. Okay. Y. Z. Okay. X, y. The first three. X, y, and z. About that, what are the opposite? X, we are saying that minus x, otherwise called we are giving x dash. Next about the y dash, z dash. Here the metal, okay, metal having lobes, Okay, these are the lobes about the d orbitals in the tetrahedral Ligand field. Okay, here are some points about that. Here, what is about that? Consider the cube. Consider a cube in which central atom placed at the center. Okay, central metal atom is placed at the center. Here, 4 ligand. Ligand 1, about the ligand 1, ligand 2. 4 ligand is there. This is about the ligand 1, ligand 2, and ligand 3, and ligand 4. The 4 ligands are approaching to the central metal atom. What is about that point? The 4 ligands are approaching to the central metal atom. Here, in this field, none of the d orbital point directly towards the ligand. Okay? None of the d orbital point directly towards the ligand. Anyhow, however, the T2 orbitals, which are the T2 orbitals? I told you that the T2 orbitals means, that means T2g. The T2g orbitals, which are the T2g orbitals? dxy, dxz, dyz. Okay, these T2g orbitals are pointing close the direction in which ligands are approaching than Eg. Which are the Eg? Eg means dx square minus y square and z square. Okay? In this field, none of the d orbitals point directly towards the ligands. However, the T2 orbitals are pointing close the direction in which ligands are approaching than Eg orbitals. Anyhow, as a result, the energy of T2 orbitals are increasing. Okay, increased by 2 by 5. Okay, increase means 2 by 5. Okay, increase by 2 by 5 delta T. Okay. And about and Eg orbitals are decreased by 3 by 5. 3 by 5. Okay? 3 by 5. This is about the diagram. And anyhow, you should be draw the diagram neatly. Once again, you should be draw the diagram neatly. For the tetrahedral complex. For the tetrahedral complex. That means the crystal field. Tetrahedral. Okay, crystal field splitting for tetrahedral complex. Okay, that is the energy level. How much orbital is there? 5 orbitals. First one is dxy, dxz, dyz, dx square minus y square, dz square. These are the 5 orbitals. These 5 orbitals in free ion. Free ion. Okay. In free ion, the 5 orbitals. What is the second step? Goes to the average energy. Average energy. Okay. Average energy of d orbital in spherical. We should write the full. Average energy of d orbitals in a spherical crystal field. Okay. But after the average energy, they have 2 sets. Okay, 2 sets. Okay. How much set splitting? 2 set splitting. Okay, 2 set splitting for the tetrahedral. Don't forget that the tetrahedral, the first one is T2G and the second one is EG. What is about the octahedral? Draw the reverse. Okay, tetrahedral, the first one is T2G. Okay, don't forget that TT. Okay, tetrahedral. Okay. The first one is increasing. Okay. The second one is decreasing. Okay. Next about here T2G means triple E, the first three. Okay, that is dxy. First one is dxy, dxz, dyz. But second one, EG means 2, double E, don't forget double E. Dx square minus y square, dz square. Okay, dx square minus y square, dz square. Here, and don't forget the value. You should be given the value. What is the value? Here, the energy of the orbitals is increases. Here, the energy of the orbital. Here, the average energy. Now here, the energy of the orbital is increases by 2 by 5. Don't forget that. 2 by 5. That's that. Okay. 2 by 5. Don't forget that. Increases. Increases means we are giving the plus value. Okay. Increase means we are giving the plus value. Plus 2 by 5 delta T. Okay. Suppose here the energy is, here it decreases. Decreases means we are giving minus 3 by 5. Okay. Minus. Decreases we are giving the minus 3 by delta T. Okay, the first one is here increases, the energy level is increases plus 2 by 5 delta T. Here the decreases we are giving minus 3 by 5 delta T. Okay, anyhow you should be learned that one delta T is equal to 4 by 9 delta naught. Okay, 9 delta naught. This is about the 3-mark question. Crystal field splitting for tetrahedral complex. You should be draw the diagram. Okay. Don't forget to write the values also. Okay. Okay. Anyhow, tomorrow assignment. What is about the assignment mean? Will you draw crystal field splitting detail. Octahedral. Okay, and one more. Tetrahedral. Okay, this is the assignment. Okay, don't write all the full. Okay, only the diagram is enough. Okay, that's I think that figure 5.10 and also one more having 5.13. Okay, the page number. Page number 154 and 155. Okay. Only the diagram is enough. Don't write all. Okay. Now draw the crystal field splitting in octahedral field. Draw the crystal field splitting in tetrahedral field. Okay. Anyhow, all of you should draw this diagram. This is a very important for the 3-mark question. Only diagram is enough. Okay. Okay. Thank you all of you. Thank you. Have a nice day.